This is not my main thing, really I'm a coder. Coffee stains and chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Chat. What up? Audio test test. Chat, what's up? Long time. Student 08. Student 08 in the building. How y'all doing today? Y'all saw some problems today. You want to send over some problems? There's a guy who booked, but it was actually his wedding, so he had to cancel. Which is hilarious. He forgot it was his wedding. Hold up. Let me fix up this. The lighting is going crazy in my room right now. Alright, we're going dark mode. Alright, what are we solving today? What are we solving today, chat? How's the audio? How's the audio? Test, test. Bro, I don't even solve that much hard, to be honest. 59? I usually just do mediums. I spam mediums. How's the audio? Audio's good? Yeah, real quick. Yeah, I gotta do real quick one. What's the leak code of the day? I already did this. Paul, what's up, man? How you doing? How's the move? Yo, Paul, let's catch up quick. I want to hear about the move. Hop on the Discord. If you're free. Bet. I gotta do another question. It's bad vibes for real. Bad luck.
Yep. What's up?
Yo, what's good, man? How you been? How's the move?
It's alright. It was long.
36
Had
hour
to drive
drive?
like 17 hours on one of the days
Holy shit.
because there was like a traffic jam in Wyoming. It was like
Yeah.
3 hours.
God damn.
Yeah, and some semi truck like right in front of me. We were on like a hill, and I think he was like reaching to grab something or something, and he let go of his brake, and he almost slammed into me.
God damn. Bro, that's dangerous, bro. Are you good at driving? AR88, where did Paul move to? He moved to Silicon Valley. He's out here now. Working.
Yeah.
He's working at
Yeah,
Meta.
James, alright.
Let's
Yeah,
get
James,
it.
we're gonna hit the lunch together or something.
Oh, yeah. I'll come through that PK. So, you already moved into your apartment and everything?
Yeah.
Damn. Dude, 16 days? You're probably like, just wanted to start
Yeah, I
right
just
away.
wanted to. I honestly thought it would take longer to like get stuff like set up because I needed a car. Because our car that we had where we were at, it was like close to breaking down. So we wanted to get a new car.
Yeah.
And like get a license and stuff and get bills set up. I thought it would take longer, but it only took like 3 days.
Now you're all set
So
up and
now
everything.
yeah, I mean, I'm still like working my old job, but I have to get up at
Oh,
like 6 in the morning.
okay. That's actually chill then. You just work. When's your last day?
Yeah,
You already handed in your 2 weeks?
no, because the last guy who came in his 2 weeks got fired like 3 days later. So I'm
Oh
just gonna
shit.
tell him like the week, the week of.
Dude, that company's crazy. They can do that. Just fire you at
Yeah,
will.
yeah. I mean, I think it's because the guy right before, because like they're getting acquired by Fidelity. So like a bunch of people are like, I don't know if it's like fear quitting or just people quitting in general.
Yeah.
But some guy on my boss's team, he like a week or two ago, apparently he just quit. Just told him like the
Damn.
day of, he's like, yeah, I quit. But I guess he
So
was only there for like 5 months, and then some other guy who was there like 7 months. It was like on a different team though, so I don't think I would get fired,
yeah.
but I don't know. So I don't really want to risk it. But the dude like put in his 2 weeks and he got fired the next day. I'm like, damn. Jesus.
The fuck. So what have you been up to since you got here? Have you been exploring at all?
Uh, Not really. It was mainly just like doing like getting stuff set up, but probably explore, probably go to the beach or something.
The beach. What beach?
Yeah, like I don't know, some beach. I take the dogs to a beach, see if they want to jump in the water or whatever.
Oh, you go to Pacifica. That's a really they have a Taco Bell right on the beach. It's beautiful. The dogs can
You
run
said they
around
have a
too.
Taco Bell?
Right on the beach. Yeah, it's crazy. And it's like a it's a different type of Taco Bell. I don't know what's
I
it called.
see. Yeah, it's got
Taco Bell Cantina or
like a
something.
deck. Yeah, it's got like a deck. That's cool.
Yeah,
I
Taco
love Taco
Bell
Bell.
Taco Bell Pacifica. This place
Yeah, I see
slaps.
it. I love Taco Bell though. I have to go
Yeah.
there.
Yeah, go there. Today's a nice day right now too. How hot is it over there where you're at?
Uh, Let me check. Like 72.
What is that? In Celsius, I mean,
Was that in Celsius? It's like
FTC. Okay,
22.3,
that's chill. Yeah,
I think.
the temperature here is mild. It doesn't get too hot, doesn't get too cold. The worst
Yeah,
you'll get is
that's
like
good.
30, but
30, like 30 C.
Celsius is like, what is that?
Yeah, so it's like what, like it's like almost 90, like 85, 90 Fahrenheit. It's not bad.
Yo, oh yeah, it barely gets to 30, like 86 Fahrenheit. So
Just use
what are you gonna
Celsius. I
do,
didn't even know they use Celsius in Canada.
bro? Everyone uses Celsius except for the
I mean,
U.S.
yeah, I know that, but I just thought Canada kind of adopted everything the
Mm,
US did because
yeah,
they kind of like want to be the US, but they
yeah,
can't.
that's too funny. So what are you gonna do now until the 20th? Just work? Are you preparing for meta at all? Like studying or
Um, Not really. It's
yeah,
like similar stuff to what I've been doing for the most part. There's no real like new languages or anything that I'll be using.
yeah? Maybe hack. Gotta use hack.
Um,
You
I
gotta
mean
learn
maybe,
PHP,
but
bro.
I'm not like I'm not like on the dev side, so I don't think I'd be using that. But I mean, if I have to, I can just figure it out. It's like I was watching do LeetCode. It's like annoying, but it's not hard.
Yeah. Oh, that's chill. How's like your girlfriend and the dogs liking it in the bay?
Um, the yard we have is like really dry. There's like no grass, so the dogs like they're like tripping because there's no grass. So they've just been like going crazy.
Bro, it doesn't rain out here too.
Yeah.
So
It's funny, the day we came, it rained for like 3 days in a row and then it just stopped raining.
yeah, you might never see the rain again for a few months.
Yeah, the guy who was because like Meta sent someone out to like look at our house so we don't get charged for stuff on the deposit if like stuff is broken. And he was saying that it's weird that it's been raining because it normally doesn't rain during these months.
Yeah. All right, man. I'm gonna jump on some leak code. Nice, like, good luck. I'll
Yeah, man.
catch you again soon.
Yeah.
I'm gonna grind
But
some leak code.
Yeah, we'll hit the MPK.
Yeah, let me know if you need to do a mock at some. If you want to do a mock, I know you already got a job and everything, but
Yeah. Yeah, you know the vibes.
all right, man. Talk to you
All
later.
right,
Peace.
later.
I have a Oway with 2K, dude. That's crazy. I want to work at 2K. Do you know what they're gonna ask? All right, chat. This is the first question. There are none water bottles that are initially full of water. Yeah, I would work at 2K. I like to play 2K NBA. So there are a number of water bottles that are initially full of water. You can exchange that non-exchange empty water bottles from the market with one full water bottle. The operation of drinking a water bottle turns into empty. Okay, so I'm given 9. So I just need to divide by 3. And then divide by 3. Oh, okay. This is just like a math calculation. So you just divide it by 3 until you get to 0. But I think you need to floor it. Yeah. You just floor it. So you just do while num bottles is greater than equal to greater than 0. There might be a better math equation for this, but what you could do is drank plus equals num bottles. Then you do num bottles divided by 3, or num exchange. And then return. Does that work, chat? Is that an infinite loop? Oh, shoot. No. I messed up. Num bottles. So what's 9 divided by 3 is 3. What's 3 divided by 3 equals 1? What's 1 divided by 3? Wow, the num bottles. Does this work? So they drink 15. 4, 8, 12. So you can get 3 back. Am I doing the math? What is this? You can exchange 4 empty bottles to get 1 full water bottle. You drink 15, you drink 3. MCQ in CPP, C++. Okay, am I off by 1? If you have 10 bottles and the num exchange is 3, your code forgets about extra bottle. 10 divided by 3 equals 9. Yeah, you're right. Wait. I just gotta do the math here. So pretend we have 15, right? We drink 15. We do 15. 15. Drank. 15 divided by, was it 4? What was that? 4, 8. Yeah, 3 bottles. We get 3 back. Right? 3 drank. 3. number of bottles equals 3 divided by 3. Yeah, 15 equals 3, right? Wouldn't this equal? Oh, this is cut it. Oh yeah, you can't exchange it. Oh shoot, I'm forgetting about the extra. You still, yeah, I just discarded them. You're right. Yo, this is why I have y'all in the chat. You're right, you're right. Because I drank them. Okay, I drank 15. Yo, James, I haven't been here, but I got a new job at PlayStation in Dublin. I've been working there for about a month there. I also got job offers from a few other companies, as well as one including Google. Just want to say thank you for the mock interviews a few weeks back. Your videos helped me like crazy. Bro, I appreciate you, man. Good job. Congratulations. This big stuff. Which offer did you end up taking? I'm happy for everyone in the chat getting some really good offers. There's so many people getting a ton of different jobs. But let's drank equals. Okay. So what we'll do is while the num bottles is greater than 0, right? What we'll do is drank num bottles. Then we'll do empty. So now we drink a certain bottles, but we add empty, right? Now what do? Now we do num bottles plus equals, we'll take whatever we have empty divided by, like, num bottles divided by, this is how many we could trade it in for, divided by num exchange. But we also need, so empty is divided by number exchange, or the number of bottles, but we still have some empty, which is the remainder. Or so we drink this one. The number of empty is the number of bottles that we can exchange. Bro, okay. We just gotta do the math. Why is this one tripping me out? I wonder if there's a one-liner. Okay. So pretend we drink, I just need to dry run this real quick. Pretend we drink 15. Now we can trade in 3 bottles. None bottles left. All right. Okay, let me lock in. So we drank the bottles. So that's 15. How many can we trade in? Well, we can trade in, the new number of bottles is going to be, okay, we trade in 15, right? Okay, I'm not looking at the chat for a second because I need to focus. We drink 15. Now we have 15 empty bottles. How many bottles can we trade in? can trade in. Oh shoot, we need to keep track of the empties. Okay. Let's do... Let me just simulate this whole thing. So we drink the number bottles, then we say num bottles. Equal to 0, because we literally just drank all them. Now we have empty bottles. We need to capture how much or how many we could trade in. So no. So how trade in? X, and then we have leftover equals Y. To trade in, we just take all of the number of bottles that were left, and then we divide that by num exchange. So leftover is going to be I can't delete that. So leftover is num bottles. How many did we exchange? Minus num bottles. Why is this one tricky? There's a part 2, don't worry. So what's the leftovers? The leftover is num bottles minus how many I trade in times the number exchange. So leftover empty, right? Okay. I wonder if we just have to simulate this. So we drink a number of bottles. We drink 15. What do we need to trade in? We need to trade in. We need to take... So this is how much we could trade in. And then that's how much we're going to... Num bottles equals... Trade in. Do we just set equals? We just need the leftovers here. Oh no, we just need to do number of bottles. Mod. Okay, let's see if we simulate this. So we start with 15. 15 drank. Trade in equals to 15 plus 0 modulo 4 equals 3. So we trade in 3. We say this is iteration 1. Trade in 3, right? Empty. So empty equals plus number of bottles, which is still 15, mod 4. So empty equals 3. Now for iteration 2, we're gonna have 3 to drink. Trade in the number of 3 plus 3 equals 6. Yeah, so trade in equals 1. Empty used to be 3. But I just traded it in. Because we do... Yeah, you're right. I could... Okay, let me simplify this. What if I just keep drinking until I can't drink no more? Bro, I could probably just simplify this with a loop. Let me think about it. If I just keep drinking and I can't drink no more, then I make empty. And then I trade in empties for actual drinks. Chad, I'm cooked right now. How am I getting cooked by this? Okay, let me take a step back. Because the empties here... Okay, wait. I drink. Okay, what is the empty? The empty is... If the 3 plus 3... Okay, the trade-in is good. But the empty again is equal to 3... Oh, I think we just need to do a mod here. Is it that easy? Like that? Just a mod? Let's go! Dude, that was the hardest easy I had to do in a while. See what the people are saying, man. Do the math formula? Is that matcha? Yeah, it's a matcha. What's the math formula? Let me read it. Oh, it's like a series? Yeah, it's like a series. Six, 3. Yeah, initially I thought you could just keep dividing it. This is interesting. Dude, there's a log solution? Optimize in the we consume in each iteration. By using math operations, we can do this more efficiently. We consume... What's this? Yo, my solution is different from theirs. I think my solution is optimal too. Like it's a log solution. Yeah, because they're doing this. Yo, everyone has their own solution. Interesting. You want to do a mock right now? Where are you interviewing for? 667. Yo, let's walk this back. Let's look at the daily question. Which one did I just do? All right, let's look at water bottles too. All right, chat. We're gonna try water bottles too. Try this out. Hold on, let me grab something. Morgan, let's run a mock. Can you email me? We can do it today. I have some time. I booked some time for ad hoc. Just give me your username and then we'll figure you out. I can figure it out from there. And mock interviews, Hi James, thanks for the insightful videos and mock interviews. I especially value the focus on clarifying and understanding the problem. It's half the challenge, shows real problem solving skills. Raid, appreciate you, man. I'm glad that you found the videos useful. Okay, let's take a look at this. Nice. Where did you interview at? Yo, you got this. Lock in. Congrats. It's not easy to land interviews. Dude, my shit's tweaking. My OBS is tweaking out. I want to do some fun questions. I don't consider this one fun.
I might finally get.
Let's take a look at this though. Yo, you got this, man. You got this. Y'all, I got the Meta glasses too. I could record with these. That's how I did my day in a life the other day. Let's take a look at this problem. You are given two integers, num bottles and num exchange. Do I get a discount on Meta products? I got a discount on this one by $150. Right, Q. Appreciate you. Yeah, I'm gonna be shooting a bunch of videos so y'all could see some of the behind the scenes, because now I have these glasses. It's easy for me to like quickly take a shot of what's happening. So I'm gonna be doing a lot of stuff this month, and I'll be making little shorts, so you can see behind the scenes of what it's like living out here. Bro, I don't want to do this question. Let's go on, what's this thing called? Zero track. Three 100. Oh, this is an easy question. It's only ranked 1366. How's the lunch in my office? The lunch is pretty good. It depends on the day, because pretty much, well, at each of the offices, well, the one at SF, there's like 4 different restaurants. So there's Mexican food, Korean food. Like, it all depends. They just switch it, but usually sometimes like American food, Korean food, Mexican food. Like, pretty much every day there's 4 different restaurants that you could choose from, and it changes every day. So food is usually good. Honestly, I have no real complaints about it. I like it better than when I used to work at startups. They would give us Uber Eats credit, like $20, $25 a day. And I like this option better, where they just make us the food, because it's a little bit more healthy. Deliveroo credit. Nice. Okay, water bottles too. They say there's only 1,300. They say there's only 1,300. All right. You are given 2 integer number num bottles and num exchange. Num bottles represent the number of full waters that you initially have in one operation. You can perform one of the following operations: drink any number of full water bottles, turning them into empty. Exchange empty into one full water bottle, then increase the num exchange by 1. Note, you cannot exceed multiple batches of empty bottles for the same value. Okay, I see. Dude, this is just an extension of the last one, isn't it? Jonathan, what's up, man? This is just an extension of this one, right? But then all you have to do is num exchange plus equals 1. Oh my god. Oh, okay, you have to increase it every time. Okay. Dude, yeah, that's like another sequencer series. I'm not calculating that. So let's like drink the number of bottles. Then we'll do like a while loop here. Okay, what we'll do is we'll drink the number of bottles, and then we'll put empty equals to the number of bottles here. And we'll say number of bottles. Then we'll say while empty while we'll say the number We'll just do a regular. Wow, drank, or sorry, number of bottles plus equals non-exchange. Non-exchange plus equals 1. While the empty is greater, then we'll do empty minus equals num exchange. So while it's empty, right? While we have enough empties, the number of bottles will increase by 1. And then we will minus empty minus number of exchanges, and then we'll increment this. And then, oh no, we need to, there's gonna be infinite drink. Yeah, you can interview. When do you want to interview? We drank this number of bottles. Something like this. All right, let's get it. Okay, what's the runtime complexity? Wow. I just straight simulated it. Who wants a mock? Who wants a mock? Yeah, I got you. Email me. We can run a mock right now. Email me for a mock. If you want a mock, you can email me. I'll be waiting. Yeah. Lead code in this job market. Is lead code in this job market gonna help? Yes, because every company is still asking lead code. Can I do? Yeah. Anybody who needs to do a mock interview right now, email me because I have a spot in the next 5 minutes. I'm free for the next hour. I can pick up whoever can hop on right now. Let's do it. I don't think Meta's gonna stop doing lead code anytime soon. I think most companies are still going to be doing lead code. Honestly, I see it shifting to you use some AI for it, but honestly, I think lead coding is still important. Jess, what's up? Thank you, appreciate you. I don't know if I'm gonna stream tomorrow. I don't think so, because I have people visiting. Let the number of times empty bottles exchanged water to be T. The total number of exchanged empty bottles be empty. Dude, it's a series. Yes, I'm fast in iShow speed. Amor, I'll be on for 2 more hours, so But just try to hop on ASAP. But I don't want to work through a series. I feel like I'm in school again. Hi James, should I focus on lead code hards if I apply for Meta, going to aim for E5? I think you should just focus on mediums and only some hards, but they usually won't ask you hard. Mostly medium. But you still need to know some hards, a few hards, because they would ask some hard questions, but not too many. Hope that answers. But Raj, yeah, you need. Yeah, Raj, you can hop on. We can see where you're at and then see how they do it. Yeah, they run lead code at Meta. They run two lead codes in the span of. They run two. You have to do 2 questions, 20 minutes each. What are the common questions you've gotten asked, like specific questions or topics? A lot of graphs, a lot of graph questions, a lot of. I made a video on this. It's the top 6 coding patterns you need to know, and it pretty much holds. A lot of a lot of graphs, honestly. Any tips for getting better at matrix problems? For matrix problems, let me think. I feel like with matrix problems, there's very few variations, so it's easier to get good at matrix problems. Just know how to navigate the matrix, know how to grab the neighbors in a nice way, and make sure that you're not indexing out of bounds. So work through questions like number of islands, Pacific water flow, Pacific Atlantic water flow, spiral matrix. Once you can get those, you should be good. And then work through some matrix questions that involve Dijkstra's. Okay, let me see what's up. Yo. For someone with 12 years experience, should I focus on lead code or system design for meta interviews? Focus on both. You need to do well in both. You'll probably learn the system design way faster than the average person because you have so much experience, but make sure you understand both. I would make sure I have a solid. I would spend about 60/40. 60 on lead code, 40% on system design. Do you think it's a bad idea to renegotiate salary after accepting a verbal offer? No, negotiate it. It's not the salary is not there until this like until it's signed, it's not official. So exactly. Know how to check the rows, know how to check the columns, the diagonals. Make sure you know how to work with the bounds. Make sure you can iterate it from left to right, right to left. Iterate it column by column. Iterate it in a spiral matrix. Just try playing around with all of those, and you should be really good with working with matrices. KS, what's up? Also, the one thing is, yeah, negotiate if you don't like the salary right now, negotiate it, because the next time, because only from here you're gonna be getting mostly incremental improvements on that salary. So if you're salty about what they gave you, it's only gonna hurt more and more as you go. Every time I accepted an offer and it was too low, then like I would just think about it way too much. Do not let them do not let them run over you. They grilled me with interviews and I did good and got the job, but my mistake was to be so easy in negotiating. Amor, do you work at Meta right now? So you took a lowball offer? That's what you're saying? You took a low ball offer at Meta, and now you're upset about it. That would be my advice too. Is never leave anything on the table.
Hi, Jake.
Yo, what's up? How you doing?
I'm good. I'm good. I just sent you an email.
Oh yeah. Let me get you on here. Yeah, if you got super low ball, that sucks.
I'm being honest, I'm not that good at lead core, but I just wanted to hop on.
Yeah, let's do it. Let me send you an invite. No, thanks for hopping on. Jess, what's up? No problem. All right, let's switch over. I sent you a Google Meet. Did you get it?
Let me check. Yeah, I did.
James,
Okay,
I live in
I'll drop
Toronto.
off from here.
All right. Yeah. Got you there in a second. Answer a couple more questions. All right, James, I live in Toronto and have about 12 years of experience, currently earning around 180K. I feel like I've hit a ceiling at this point and it might be time for me to aim for something bigger. What do you think? Yeah, if you've been working for 12 years and you are making 180K, from what I know, that's a lot there in Canada, 180K. You probably are hitting a ceiling. So, I mean, there's multiple ways that you can pass that ceiling. You could try to find another job, but most likely it's going to be hard to find another job that makes more than that in Canada. You could make more incrementally, maybe to 250K, maybe 300, but that's not going to change your life too much because you already make 180K. So I would just find other things that you're interested in as well. Like for me, when I hit a ceiling, I started reading more books, started making this YouTube channel, different things like that. A lot of companies pay, but usually they're in the US companies. Alex, what's up, man? Yo, I gotta hit Vegas. Raj,
Hi, Jake. How are you?
I'm good. How you doing?
I'm doing great.
I'm gonna send you a link.
Okay.
Alex, I see you're having too much fun out there in Vegas. Too much fun is what you're doing. Or having fun is what you're doing. I'm trying to do that too. The taxes aren't 56%. All right. Okay, let's get this. It's tripping. You're in? All right.
I am.
Cool. All right. Who do we have here? Can you introduce yourself?
Yeah. Hi, guys. I'm Raj, and I'm currently a master student at ASU. So, I've been looking for summer internships, and I thought I should just hop on.
Nice. So you go to Arizona State University,
Yeah.
Masters in Computer Science?
Yes.
Nice. Cool. So what kind of jobs are you looking for right now? What kind of internships?
Uh, Mostly software engineering and AI ML focused because I
Oh,
have a background in that.
you're smart, man. What was your bachelor's?
Oh, I did my bachelor's in electronics, but I switched to computer science now.
Oh, okay. I see. So how are you at LeetCode? You think you're gonna be able to get these today? You're gonna do good or no?
I'm not really sure. So it's just that I want that initial kick for me to get started, to know where I am at right now,
Yeah.
because I've been like just being lazy, not been solving problems. Maybe this will be an eye opener for me.
Yeah. So when did you tune into to the stream? Just right now, or you've been here the whole time?
No, not the whole time. I think it's been 15 minutes, but I've seen your streams before, so
Did you see me solving the last questions or no?
no,
Like, did
no,
you
I
see me
didn't see.
solving anything?
So yeah, I have seen you solve questions before.
Okay.
I've seen one of the videos in which I think there was a really good competitive programmer that you had on,
Oh, okay.
and and he solved the hard in like 20 minutes or so.
All right. Okay. I'm gonna ask you the first question. We're gonna spend about 40 to 45 minutes in this coding
Okay,
interview. We're gonna spend about
sure.
20 minutes per question. And the first one, this is the first question I'm gonna give you.
Okay,
And treat it like a real interview. Ask me clarifying questions. Tell me your approach. Go ahead, and then we're gonna try to implement it and get something working.
okay,
But this is the first question. I'll say it out loud real quick. So we're pretty much given num bottles of water. This is gonna be a variable, a parameter, and
okay,
this is how much waters bottles that you have that are initially full. After you drink them, you can exchange them for, and it costs like you can exchange a certain amount of them of empty water bottles for a full water bottle. So num exchange is telling you how many bottles you could exchange empties for one full water bottle. Just
okay,
need to tell me the number of time number what's the maximum number of water bottles that they can drink.
okay. Could you just walk me through an example?
Yeah, for sure. I'll just post the example and you should walk through it yourself and then let me know.
Okay. Input 9 bottles, number of exchange
Rafi,
3,
what's
output
up?
is 13. You can exchange 3 empty bottles to get one full water bottle. Number of water bottles that you can drink, 9 plus 3 plus 1. Hmm. So number of bottles are like full water bottles here. So when I'm drinking one bottle, I suppose it gets empty.
Yep.
And I can change that with one of the exchange bottles.
Exactly. So you start off with 9 bottles, right? So you drink all the water bottles. Now you have 9 empty.
Yeah,
You can exchange 3 empties for one full. So since you have 9 empty, you can get 3 more water bottles. So that's why you drink three. And now after you drink three, you have three
okay.
empty again. You could exchange it for one water bottle. Now you drink that, and now you drank 13 in total.
Okay, so number of exchange is the minimum number of water bottles that I'm using to get another bottle, if
Yep.
I'm getting it right.
We can repeat
Okay,
that.
so the number of exchange is the minimum number of bottles that I require to get one more water bottle.
Yep.
So if I walk through the second example, that would be if I drink 15 bottles, that's like 15 empty bottles,
Yep.
and 15 modulo 4, that would be like 3 more bottles. And using those 3 more bottles, and how many do I have? How do I get that one extra bottle? 15. If I
Well,
exchange.
well, you drink 15, right?
Yeah, I drank 15, and then basically for 12 bottles, I get three more. Like if I give 12 bottles,
Yeah.
I'll get three more new bottles. And okay,
Now you have 3
okay,
empty left over.
I see. I see. Uh, I have three left over, and I have one more. So, like, I can exchange that as well.
Exactly.
So, okay. So what I can see here is maybe I could start um, with basic division, like how many bottles I get after each iteration. Mm, okay, let's just do basic division first. So I'm just naming it a solve function. Or do we have any kind of function names over here? No, right?
You define the function, you define the parameters and everything. But yeah, I think we should make a
Okay,
function that takes in these parameters and just
yeah.
returns the number.
So I have these two variables that have been given. That's number of bottles, and then I have number of exchange. So let's say we are keeping a track of total bottles that I can drink, and we can also keep empty bottles. So the first thing I would do is basically try to get how many uh, uh, plain number of bottles that I can drink. So that would be like total drink plus the number of bottles that I have. So that's straightforward, like how many bottles
Oh, Alex, I got the meta glasses
I'm
too.
able to drink first, and then how many I
I
can
know you have them.
exchange would be uh get new bottles. That would be my total drink by number of exchange. So this would get me new set of bottles.
Yo, that's a shit ton of easies.
And if I have any remaining bottles, that would be
But you did a lot of mediums
like
though.
total drink modulo. Okay. So based on my first example, if I just try walking through this, so total drink would be oh, keep forgetting it's Python. Total drink. Let's just go through first example. Number of bottles would be 9
Yeah.
after I drink all the bottles, and then get new bottles would be total drink by number of exchange. That would be 9 modulo 3. We get 3. And once I drink those total, oh, I think we did this wrong. This would not be the remaining bottles. My remaining bottles would be the bottles I drink back again. That would be 3 plus anything that was left over here. That would be basically, so 9 modulo 3, that would return me 0. So this should go on again and again until nothing is left. Okay. Uh, how would I do this? Bottles. Keep subtracting this.
Get new bottles equals total drink divided by number of exchange. Remaining bottles total drink.
Let me try with the other example. Maybe that would be more intuitive for me. First, I get 15 bottles. Then I would get total drink by number of exchange. That would be 3 bottles. And then I would have remaining bottles as the 3 new bottles that I drink plus total drink that I have.
I mean, let's try to work through the first example. I don't think the algorithm works for even the first.
Okay.
Look for the first example.
Okay, so first example, we had 9 bottles, right? And if I drink all those 9 bottles, I have total that I've drunk is like total is 9 bottles. And then uh, using those 9 bottles, I get 3 new bottles because like I exchanged it using 3 for 1. So I get total 3 new bottles. And I have 3 new bottles, and basically if there were any leftover bottles, because if it's not completely divisible, then that would be my remaining bottles count. And then I would again divide it by my number of exchange. So that would give me 1. So that would be 9 plus 3 plus 1.
Okay.
So this is kind of repetition step, remaining bottles. So similarly, I would do it for this, like total initially I drank 15 bottles, and
So like
then
like this code right now is gonna work for 9.
no, this won't work. I have to make a
Oh,
change. This is not a loop right
okay.
now.
I see. Okay.
It's just that I'm trying to see like how I will build the loop.
I see. Okay. Makes sense.
I'm just dry running it once so that I can write the loop. Get new bottles would be 15 divided by 4. That would give me, I would get 3 new bottles. So remaining bottles would be 3 plus 15 modulo 4 that are not entirely divisible. So that would be 50. 3s are 12. 3 will be more remaining. Age. Okay. D model 4 is 12. 3 is remaining. Total 6 are remaining. And now I think I can just do get one more bottle here. So the final answer would be 15 plus 3 plus 1. That should be 19 bottles. Again. Okay. Okay. I keep subtracting this, getting new bottles. So maybe we can just keep subtracting from the initial number of bottles that we have s- until they get over.
Mm-hmm.
So I will do a while loop, and the total count is like total drink. So initially I would add all the bottles. Once I do that, uh, I need to get number of new bottles, right? So my new bottles would be like total drink by, so this would be like how many bottles I have left. So that was this part. Mm, do I have extra bottles as well?
Alex, never heard of them. Never heard of them. Why? What's up?
That would be total drink percent number. Extra bottles. Keep adding it.
Yeah, usually I mute. I mute while I speak to you too.
I think
Depends.
this should work.
Okay.
Oh, sorry. Total drink. My bad. Yeah. Initially, we had 9 bottles, so total drink will get 9 bottles. New bottles, we would have 9 by 3. So those are like the new bottles. If I have any extra remainder bottles that I'm calculating using total drink by, oh, okay, total of 16.
Okay. New. This is the new bottles. Extra bottles equals. You sure?
Let me just think it through. Because the next time I want to walk through 15. Let's see, 15, and then 15 by 4, that would be 3, and then extra bottle, extra bottles would be 15 by 4, 3 again. It's 3 plus 3, 6. Now I have 6, but I can't add all those 6. It doesn't make sense. 6 won't be here.
So where are you looking right now? Like where do you think?
This line will cause the error because if I am adding the remaining bottles as well as the new bottles that I have, so it will get added to my total drink, but that's not what I want. What I want is, oh, if I do that. One and extra bottles would be 2, 3, 3 by 4 is 0. Okay, this should work.
So we're getting the number of bottles equals the get new bottles plus the extra bottles
Yeah,
divided by number of exchange.
yeah,
Okay.
that
Let's
should be the update
let's
for.
dry run it with the 15.
Okay.
What's up with all this code here? Are we deleting this or keeping it?
Yeah, we are deleting that
Okay, delete
thing,
that.
and we are not using empty, so
All right, let's dry run this and let's see if we get to 19.
15, 4.
Or dry run it for me. Maybe we could try running it. Just looks like it's an infinite loop. Walk me through a line by line and show me how this code is working, and then for this example, and we'll just debug from there without running the code.
Okay, so I have 15 bottles
Yeah.
and number of exchange as 4. So while 15 is greater than 0, what I'm trying to do is I'll add the 15 bottles first to my total, and new bottles would be 15 by 4. That would be basically 3.
Let's get new
And
bottles,
extra,
right?
yeah, get new bottles, and extra bottles would be the remainder. That is 15 by 4. Oh, that's like 3x. So my new number of number of bottles that I'm again replacing it with is basically 3 plus 3. That's get new bottles plus extra bottles divided by number of exchange. So that would be
Why are we
one.
adding extra bottles there?
Because when I was walking through, you saw, right? So extra bottles were not completely divided because I can't exchange them for a new bottle. So to complete that whole exchange of bottles, I need a minimum number of bottles, right?
Okay, because 3 new bottles plus the extra bottles. What does extra bottles represent here? If we're
So
this,
15 is not completely divisible
yeah,
by 4. So those remaining bottles,
but those are empty, right?
yeah, those are empty bottles. So I could not exchange them completely. So I would exchange all those bottles which were possible to exchange. So those got me 3 new bottles. So I'll drink 3 new bottles. So now I have 3 empty bottles and the 3 that I could not exchange before. So I'm adding the 3 that I did not have. So the 3 that I drank newly plus the 3 that were present before. And I add them, and then I again divide it by the number of exchange bottles I can get from the newly available empty bottles.
No, I get it. I don't think this operation is gonna work for you though. Number of bottles. Because okay, number of bottles, right? We have pretend we exchange for 3 new bottles, right? If num bottles equals 1, when we loop again, we're only adding 1 to the total drink. So it went from you drank 15, then it's only gonna go to 16 on the next iteration.
So the next iterate, no, so here itself, the next loop would be like if 1 is greater than 0.
Exactly. Then it's just
And
we'll
then
add 1 here.
it should be adding 3 as well. So I think I'm missing this part. Oh, total drink
Alpha, did you already solve this one?
plus equal to get new bottles because I was not adding this 3. This should be added to my total count. So that would be 15 plus 3, 18, and then this goes next and it gives me 19. Am I missing something? Mm, okay, just let's
Yeah,
walk
take a
it through
step back.
again.
Take a step back.
Yeah, yeah. I think I'm using a lot of variables and making it harder for myself.
Like you're kind of doing 2 iterations in one, or like two
I'm
iterations
doing,
worth of work in one, because you're adding again to the total. You said you're gonna add to the total again, or
yeah,
you removed it. But okay, take a step back and think about it.
yeah. So what we are doing here basically is we have number of bottles that were my initial count, and I drank all of them. So now I have empty bottles, which is equal to my how many I have drunk. So number of bottles. My number of bottles would be my empty bottles. Change. I had 15. So 15 by 4. 3 bottles now. Okay. The remaining bottles are so my number of bottles would always be my empty bottles that I have and how many I can exchange. But that does not fix my empty bottles problem. Do I drink the total bottles?
So what issue are you facing right now?
So I'm thinking if uh, I have my number of bottles that I'm getting, which uh, is basically I can exchange my empty bottles with using the number of exchange quantity.
Sure.
Those will be like my new bottles, and I can drink them again.
Okay.
Uh, but I want to update my empty bottles as well because in the next loop, uh, so if we were seeing here, we had something like 15 modulo 4. I had 3 extra bottles, so that should also be used in my next loop.
Sure.
So these 3 bottles, if I want to use in my next loop, uh, how would I do that? Maybe. I don't have anything. Okay, if I have 3 here and I had 3 before, so 3 plus 3 is 6.
Okay, we're good. Let's move on to the next question because I want to get your sense on the next one. It's I'm gonna
I think I
post.
got it.
Or you got it?
Yeah.
Okay, what are you thinking?
So what I'm thinking is basically I keep on updating the empty bottle since I'm using that for exchanging. And to update it, I can get that again. So this should, using my empty bottles, this should be added to this part. Total drinking.
Okay, let's come back to this if we have time. I want to get
Yep.
you to the next question. So, question 2.
Yeah.
So, we're going to be given a positive integer n.
Yep.
We need to break it down. Like, I'll just show you the inputting. Just look at the examples.
And 537, 500.
Yeah, we're going to be given a positive integer n. We need to express n as a sum of only base 10 components using the fewest base 10 components as possible. And explains you what a base 10 component is. But you could see 537 could be broken down as 530 and 7.
Okay. Uh, 530. Hmm. Okay. Hmm. Okay. The first thoughts that I have are like basically keep on dividing it by 10 and keep on getting the remainder, like the last digit. So basically, if you have something like 537, this should, uh, so when I first get the last digit, that would be 7, and I have 10 to the power 0 with this, and in the next loop, when I'm dividing it by 10, that should give me, so I have 537 and I remove 7 from it, so I have 53 now. So 53, I get the last digit from here, so that should be like 3, but now I have like 10 to the power 1, and then I have just 5 remaining, so that should be 10 to the power 2, 530, and 7. That's like the example 1.
Sure.
If I have to write this in code, so define, we have been given an integer n, and we have to return a list. So I'm initializing a list empty list answer. So while n is greater than 0,
Yep.
I want to keep, so 537, how would I do that? I want to keep a counter p, which is basically like the power. And for p, if I want to keep it greater than, I'll keep on incrementing the counter. 7 divided by 10. And 537 divided by, this should give me the last digit. And basically I would append my last digit into 10 to my power. So this would give me what I was trying to show over here. Basically, I'm multiplying it to the power that I have currently. That would give me the current digit
Ruben, congrats, man.
over here. And this should,
Dude, that's big news.
we should increase the power basically, and the new number would be divide by 10 every time.
Okay. Wait,
This
take a
should,
step back and just make sure that I don't want you to run it. Just look over it and just make sure that it is gonna work on all cases.
okay. 402. If I do a modulo, that should be turning 2. Okay. I see. If I'm doing, this would fail for this case. If I'm taking 102, my first would be 2 to the power 0, but then I have 10, so my last digit, 10 divided by 10, 10%, 0, but I don't want to append 0 to my answer. So for this particular case, in which basically we have, so when I'm removing the 2 from here, we should get 100. But with the current logic, if I'm doing 10 modulo 10, that would return me the last digit as 0, and 0 to the power anything is 0. So this would not work. So if we have last digit that is equal to 0, how would I do this? Meaning len 10 to the power 2. This would be brute forcing it. par. Did this work?
We're just gonna break out.
Yeah, so if it's perfectly divisible by 10, what I'm trying to do is convert that into string, and then I have like length of string is 2. So 10 to the power 2, that's 100. So I append that to the answer and then break it out.
Okay. What if we have like the answer is like 1,000 or the input's 1,000?
So basically 1002, something like this.
Yeah.
So for 1002, I'll get my last digit using the first logic.
Sure.
The remainder is 2, and then I have like length equal to 4. Because 1000 is completely divisible by 10, so this remainder would give me like last digit as 0.
Sure.
And here is where basically the new n is basically the current number, that's 1000, and uh, the length is 4, so 10 to the power length minus 1.
I mean,
Yeah,
what if we have 4 right here? That's divisible by 0.
14002. This, I'm taking this out. And then we have 2, that's this thing. Okay. Sure. Keep 400. So this should be potentially giving me answer that should look like this: 1000,
10,000.
10,000, 4,000, and 2.
Yep.
But this code won't give you that. I'll get 2 out, but then I just get
You just break out.
14. So I just get 14,000. So the current code would give me this answer, but that's not what we want. We want to have this thing.
Exactly. Exactly.
Okay. New and 1400. Star length. Should I do that? Okay.
Which part are you thinking about?
I mean, this won't work for this, so I need to make changes over here because the remaining part does work for the normal cases. So I don't think so there's anything wrong in these 4 lines.
Yep.
uh, the only case I need to think about is when it's like so now I have 14,000. If I'm using this logic, uh, it's incorrect.
Yep, exactly.
Mm,
Oh shit! I just noticed we're at 45
okay,
minutes. Yeah, so we'll just end it there. How do you think you did? How was that?
I would say below par.
Yeah, like how do or yeah, how's that experience on your end with where do you think were your gaps?
I feel I'm not able to take it till the end.
Mm-hmm.
I wrote the logic, but I was not able to provide concrete examples which could actually lead to a solution.
Yeah, I think yeah, my feedback would be yeah, definitely you have good intuition on how to solve it, but you just had a lot of trouble with the final edge cases and getting it across the finish line. I think your
Yeah,
overall process wasn't bad. You honestly you didn't clarify the question too much, but so you
okay,
should ask some clarifying questions of like some edge cases and like is
right.
at least ask one or
For
two.
here. So I got to know as we went through the process, after coming across a few examples, like you gave me a few more examples, then I got to know, oh, this might be also the case. That should have been my clarifying question in the start.
Yeah, exactly. Just like usually they'll mark you that you clarify a couple questions, so read through it and just think about what the edge cases might be, because at least it's in your head. So just make sure the
I
input
see.
is good. Make sure you probably wouldn't have caught that edge case right away. You might eventually catch it, but you should just clarify some of the inputs and outputs and anything that you any misunderstandings with the question. But overall, I think your process is good because I didn't have to worry about you starting to code right away. You kind of started coding at a reasonable time. When I
Yeah.
got to understand, you came up with some solution and started coding it. These questions were both at the easy level, so I was expecting you to solve both of them in order to pass the interview. But
Okay.
yeah, I think for this second question, right?
Yeah.
You had good intuition, but you overlooked a couple things, as in you just returned the answer, but you actually need to return the answer in reverse order.
All
And then
right.
like for this edge case, you could just skip if you see the last digit is equal to zero and just let it iterate one more time. Like skip adding to the answer for that iteration. And that would have solved the case there.
Could you come again for the last digit?
So if the last digit is equal to zero, you could just only add you could pretty much only add it like here if the last digit is not equal to zero, and I think your solution will work,
Oh,
right?
okay. Yeah, 14,000 would be last digit. I see. You only make those changes like for 4,000. If you want that 4,000, the last digit would not be zero. That's like four, and then you append that power to the answer. Similarly for, yeah, I see how it works.
Yeah, like if you take the last digit to zero, just don't add it, because
Yeah.
when you multiply it by 10 to the power, it's going to be zero anyways, so skip it, but increase the power and make the number smaller again, so that
What
would
about the first
capture.
one?
Pardon?
What about the first one?
The first
The
one.
first,
Yeah, we'll work on the first question as well.
yeah.
But that small change. So I think working with those edge cases, adjusting your algorithm for the edge cases is just where you couldn't get it, but you had good intuition even with the first question. But even with the first question, you just had trouble managing empty bottles carrying over.
Yeah.
So just work on making sure that you can carry over the empty bottles correctly. And this one's a bit tricky. That's why I gave you a little bit extra time. But I would still expect you to solve that one within the 30 minutes. So I think you have
Won't
good
this
int.
work?
Or go ahead.
Won't
This
this
work?
work? This should work.
Let me just run it. So you have a total drink equals to 0. So you drink the number of bottles. The empty bottles plus equals total drink. Okay. Now the empty bottles, number of bottles equals empty bottles divided by exchange. Number of exchange. So there's how much bottles you have. I mean, it might work. Yeah, let's see. Let's see if it works. Let me run it.
Okay.
Looks similar to mine. Looks like it's running into an infinite loop. I can't verify it right now, but none bottles. Yeah,
Should
yeah,
not.
you're running into an infinite loop here. Number of bottles equals empty bottles. Yeah.
No, so I'm actually adding those empty bottles. I'm carrying it over. If you see, I updated on line 31, and then I add the total number of.
I mean, watch. Let's run this thing. Look, it's not stopping.
Uh, 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 okay. Can you
Yeah.
change the variable on 29 to number of bottles? Empty
Like
bottles
I'm
plus
running it
num
here
bottles.
I'm running it here in this editor.
No, oh,
Nice.
yeah, I can see number 29 line. If you could just change the total drink to num bottles.
Or you do it right here because it's interactive.
Oh, I can. Okay. Sorry. If I go here, I think I was carrying the total number of bottles, but instead I should just carry. Yeah, that should work.
Okay, well, I can't really. I mean, I'm down to run it, but it's like over time now to see if it works. Yeah, nice. Cool. All right. Yeah, that's pretty much it. I
Yeah.
think, yeah, just see, you have the right intuition. It's more just getting to there faster. So just methodically breaking the question down, because you kind of like just the empty bottles carrying over. You could have got to there faster by just
Yeah.
realizing that was the issue and then focusing on that issue, or like dry running it and just
Maybe
yeah,
I should take a pen and paper. I was trying to do it in my.
yeah. You were dry running it in the comments, so I think it's just more practice. Honestly, the skills are there. It's just doing it on the fly. This question was tricky for me too, but I think for me, it just I had to take a step back and really think what's happening, and then reassess my algorithm and then see where it breaks, then try to fix that, and then reassess where it breaks, try to fix that.
Yeah, I mean, if I was solving this question on lead code, I would have done it this way. But in interview, I would expect myself more to actually do that carryover thing in a better way.
Yeah. Overall, yeah, I don't see any reason why you couldn't pass this interview if you just did a little bit more studying. No fundamental issues with how you approach problems and how you problem solve. So it's just clearly just get more repetitions in and just solve more questions and you should be good.
Yeah, I mean, uh, I would again go to solving those standard set of questions, but I don't think so. Those help.
Pardon?
The standard set of questions, like we have the neat code, we have grind list, we have blind list. There
Yeah.
are a lot of lists around.
Yeah.
Like, how do you prep? So if you have an interview lined up,
Honestly, those questions are outdated. That's why I made my own list too. I'll send you it right now. Try these Peralta 75 questions. These are more legit questions. I pretty much went through all the questions that I've been getting asked in interviews and that my friends have been getting asked, and I made this list. So
yeah, that would help.
the, like the Peralta 75 list is a better list, honestly. Blind 75 is kind of outdated. NeetCode 150 is good for understanding the basics and getting up to speed. But my list right here is pretty much what companies ask right now as of 2025.
I see. I'll go through them. I mean, probably
Yeah.
the interviews will start around January, February. So I just want to brush up everything before that.
You got this, man. You got this. All right. Thanks for taking the time out. Good job.
Thank you.
All right.
Thanks for interviewing me.
No problem.
It was fun.
I'll see you.
Yeah.
Have a good
Thank
day.
you. Bye bye. Good day.
Bye. Of course, I had to market it off. Then I had to take shots at NeetCode and Blind 75. That's what I do. We're part of this internet world now. We need to know how to internet beef. He sucks? Yo, what's up?
Can you hear me now?
Yeah, what's up? How you doing today?
Good, good. How are you?
Pretty good. Have you hopped on this stream before?
I have. I think I was on. I think it was once, maybe twice. I think once. I think it was once.
How long ago?
That's been. I think it was in August.
Ooh, that's long.
Yeah, yeah.
Yeah, how you been?
Good. How have you been?
Pretty good, pretty good. What have you been up to since August?
Just interviewing. I guess being on the grind. I just restarted my lead code journey. I've been kind of lacking in DSA. I'm not gonna lie. So I just started the lead code 150 from scratch, like 2-3 years ago.
I see.
Yeah.
So, could you remind me again what school you go to, or how many lead code questions you solved, and what companies you're aiming for?
Yeah. So I go to British Columbia Institute of Technology.
Oh,
That's
yeah.
in BC. Solved. I think it's around 120-ish. Yep. And then companies trying to go into. I'm trying to work my way into big companies like Fang and Quant. So I've had some experience. I'm also going to be heading into Shopify for January.
Nice, congrats.
So thank you. I think the next stop for me is trying to get up the ladder and try to get into one of those bigger tech companies.
Nice. So only 150 questions?
Yeah, like a little under that, maybe 120.
All right. With big tech, you gotta ramp that, honestly.
Yeah, I know I'm lacking, but
All right, let's see where you're at. What did I ask you last time?
it was can't remember. One of them was the temperatures question, I think,
Oh yeah.
and then I also had. I can't remember what the first one was, but yeah, I remember I mentioned like I was kind of lacking in sliding window and graphs.
How are you doing at those now?
Not great, not great. I'm restarting my journey now, so I'm just trying to work my way up by pattern.
Yeah. So what patterns have you covered now?
Right now, I just went through all the strings and array style questions. I think I'm pretty decent at sets and hash maps. I think I'm okay at linked lists as well.
All right.
So those are the main
Okay.
ones that I think I've been working up
So-
recently, and then heading on to the other ones after.
All right. So I'm gonna ask you a very easy tree question. I don't know if it's very easy, but it's marked easy.
Okay.
Right. So we'll start this off right now. The best way to learn trees, since you haven't gotten to it yet, is just straight up just do a question.
Yep. Exactly.
So you see where you're at. We're gonna be given a root of a binary tree with unique values.
Mhm.
And we're going to be given values of two different nodes in the tree.
Okay.
Return a boolean true if the nodes x and y are cousins, or false otherwise.
Okay. So cousins. Okay, true or false. Otherwise, two nodes of binary true cousins if they have the same depth with different parents. So essentially, they're on the same level in the tree. Correct.
Essentially,
Or-
that's yeah. They should be at the same level, but that's not the only thing.
Yeah, so read over this again, just make sure I have a good understanding. So given the root of binary tree with unique values and values of two different nodes with the tree x and y, return true to nodes corresponding to the values. Cousins or false otherwise. Okay. The values. Okay, so our inputs are going to be root, and we're also going to be given values x and y, correct?
Yep.
And those are probably going to be integers. I'm assuming. Turn true if the nodes corresponding. Okay, so do we want to just pretty much find nodes x and y and then see if they're cousins or like they're on the same level?
If two nodes are in the same level,
Mhm.
does that guarantee that they're cousins?
Well, same depths with different parents. Okay, so nodes it's a binary tree. Root is at
You
the
get my
depth
question
0.
here? You get why I'm asking that, or no?
Not really. So okay,
So do you have any siblings?
yes, one.
Are you all cousins?
No. Oh, I get what you mean. Yeah. So essentially a level apart. No. So goes children. Okay. Children of Egypt. So I'm just gonna draw like up a little, maybe like a little mock test case. So for example, if we have a binary tree with like 4,
There's a drawing here, drawing feature if you want to use that. You want to leverage that.
oh, this one, okay. Do I just use? Is there a
Click 7, or
that's
yeah.
7? Okay. So we have, for example, have like a that is a little too thick. Okay. So for example, if we have like a 4 is our root, and then we go down, and this is like 5, this is like 3. This goes down to like 1 and 2. This goes down to like, let's say 6. So this will be a root. This is, so like, these are sibling nodes. For cousins, would it be, are you trying to say that they're one level apart? Kind of?
No, they're the same level.
Mm-hmm.
Or line 5 gives you the exact description of what cousins are in the code. So two
Different
nodes,
parents. So
if they have the same depth with different parents.
So example, like 1 and 2 would be cousins with 6.
Yeah.
Okay. Different parents, same nodes. So okay, so now given the root, so given x and y, return true if the nodes corresponding to the values x and y are in the cousins. Okay, so we pretty much want to see if, for example, if X is 1 and 6 is Y, do they have different parents who are on the same level?
Yep.
Okay. So we could, based off that, since we're kind of doing a level-based approach, I'm thinking we could do like a breadth first search,
Sure.
just so we can go through levels. I'm trying to see. Are we given a? Are we given? Are we allowed to modify the root node, like class, or no?
We shouldn't modify
Okay.
anything. You should just be given the root,
Mhm.
traverse it somehow, or just figure it out based on. Don't modify the data structure, because pretend I give you nodes and the nodes are real data in our database or something.
Okay.
I don't want you modifying it. I just want you to figure out the question given the data.
Okay. So we can go. So if we go down vector search, we'll see this only has one. And then we could see actually. Also nice. And they have different parents. Okay, so we go down. Let's say this is not X and Y, go down again. This is X, this is Y. Actually, we might be able to do, instead of, okay, so I think instead of, we could do like a recursive search where we go down the left and we go down the right, and then we find a node that's equal to X and Y. So we'll say that if the left one's equal to X, then return true, and we'll also keep track of what depth it's on. And then on the right side, we'll go down and we'll see if, okay, if we find Y on the right side, return, yeah, return true in the depth that's on. If that makes sense.
Sorry, can you repeat that?
So yeah, the approach I'm kind of thinking about is we could do like a kind of a approach where we can recursively go down like the left and right path, and we'll look for one,
Sure.
the value like X, and then also return what I guess level it's on, and then we'll go down the right path and look for Y and return what level that's on. And
Okay.
then once we come back up, we'll see, okay, are they on the same level? Like we'll know it's just assuming we have like I'm still like thinking about how to keep track of that, but assuming it comes up and we know that we have the value Y and X, and they return, like, for example, the level and it matches, then we know that it's true.
We know it's true if they're on the same level.
Or yeah, if they're like different parents, since we're going down left and right path, so we know that this is going to go down this way, so it can't share a parent from this side.
What about 3 and 5 here? What if the nodes are 3 and 5 that they give us?
3 and 5.
Yeah. What if they give us X equals 3, Y equals 5?
But that's still, would they be? Oh, no, share parents,
Yeah,
right?
share
So
parents.
4, yeah, 4 would technically be the same parent. Okay, so I could do. We could do a breadth first search with a queue that checks if the size of the queue currently has at least 2 parents, and if it doesn't, we can go down a level. And then we can end up here. And then now that we do have 2 parents, or that work 2 parents, and then we can check the nodes of the children, compare children. Accessor, the size is less than 2. Okay, so right now I'm thinking we could do a breadth first search that kind of traverses down. Like, so for example, our queue is offered 4 on the start, and we can say, okay, if our queue is less, the size is less than 2, meaning we don't have at least another parent present, we can go down a level and add children of 4, and then just continue our search. And then once we get to 3 and 5, we can. Wonder if we can add our.
So which part are you having trouble with right now? Is it finding out if 2 nodes have the same parent?
I think it's more so making sure that we get to, making sure we get to like a level where there's at least 2 parents. So the approach I was kind of thinking of is we push. We have a queue BFS. If our current size is less than 2, so we don't have at least 2 parents, we can go down. Now we're here. We said, okay, now we have at least 2. We could technically push the children in, and then maybe run a search on the children. That's
Why
kind of what I'm trying.
why do we need to know there's 2 parents?
So, because cousins have different parents.
Yeah, but do we need to know the number of parents, or we just need to know the parent of that node?
I guess we can just know the parent as long as the parent is different than a different. Yeah, as long as the parent is different. Mm. Actually, so we can. We can keep track. Actually, yeah, we gotta keep track of y as well, y and x. Q. Okay, so if you go persistent Q, go down. So that's 2 children.
Okay, let's take a
This is
step
good.
back, right? Let's for each node, we just need to keep track of their depth and their
Yeah.
parent, right?
Mm-hmm.
That's my hint.
Okay. The depth and parent, so
So
let's see.
pretend for every single node we know their depth and their parent.
Mhm.
If I were to ask you if two different nodes were cousins, would you be able to tell me?
If we had depth and parent.
If for every node we knew the depth of that node and the parent of that node,
Mhm.
if I were to ask you if any two nodes were parents or siblings or sorry, cousins, would you be able to like figure that out with the data that we have?
Yes.
How would we do that?
We could, let's see. Oh, well, actually, we could actually peek if we're at like this level, like 3 and 5, we're at the parent level. We could actually probably peek down at the children, seeing if they're X and Y, assuming we're at a parent level. Or then yeah. Okay, so I'm just like blanking right now.
So would you be able to run a DFS and and like store in maybe some data structure a mapping between the for a node and its parent? So we could easily query it and be like, what's the parent of this node? What's the parent of this other node?
Yeah, we could do a hash map for that.
Okay. What if we did the same thing with depth as well?
What do you mean? Like,
Being able to have a mapping between a node and its depth.
mm,
Like build those two data structures and then later we could just run a query. What's the
yeah.
depth of X? What's the depth of Y? Are they in the same depth? Okay, if
Mhm.
they are, what's the parent of X? What's the parent of Y? Are they the same parent?
Yeah.
I mean,
Yeah. So I feel like there's a better solution to that, though. That would be like pretty computational. I feel like this. I should be able to do this in a single pass.
Yeah, you can.
Yeah.
You
So
don't need
that's
to
kind of
do a whole hash map, but
yeah. Because I'm trying to go for a bit more of an optimal solution here. I wanna
so for the approach that I explained, what would be the difference in time complexity?
so I know there'd be a pretty big difference space complexity wise, but for time complexity, let's see, we would iterate over everything, and then we'll have a hash map for tracking one depth, and then the one. So that would be O of n just going over every single node. Uh, Actually, but we only need to keep track of x and y, not all the nodes.
Mm-hmm.
So, but it would still be O of n to go over all of them, and then at the end we would have to compare if they both exist as a constant comparison.
Yeah.
Yeah, and then so it'd still be O of n.
Yeah, like the
But
runtime is not going to change. Maybe the
yeah,
space, but you just talked about a way to optimize the space.
yeah. Um, I think though if we do okay, so if we yeah, so I guess that would be. I'll try and just implement that and see if I can come up with a better way to approach it. Were we doing one question or two? Sorry,
Two,
just wanted
two.
to. Did we have time?
We'll get to yeah. We'll go ahead and try
Okay.
implementing it and see where you get
Okay.
to.
So, is this going to be a run? Like, do we want to create a class? Or do you want me to just go into
Just go into the algorithm.
Okay. So, hash map. Let's just say. Okay, this is going to be done in. I'm going to be doing this in Java, by the way. I should probably
Sure.
switch that. And class solution. So we'll probably need. We're gonna need our queue. Yeah, queue. Actually, we're gonna be doing this hash map approach. Let's just create some maps. One. Two. So one would be for tracking. We wanted to track depth. So node would be, let's just say, if we find a node with the value x, then we'll. Do we need value actually? We can just. Do we actually need to keep track of the node as long as we know x exists in the depth? I'm wondering if. Okay, I'll just do it for now. Instead of this, instead of having a hash map, I'm actually wondering if this, instead of keeping track of the node with the value x, as long as we know that it exists, could we not just keep track of the depth and compare?
Yeah, like you don't have to do a hash map. Like you could just store X and Y, but like don't overcomplicate yourself because we've already spent 30 minutes on it. Like just get a solution up. Like you're only optimizing very little things right now. So just focus on getting something out.
Okay.
Like as long as you know where it's going, just go ahead.
Okay. Okay, so I'm just gonna go down with. Let's just have one. Let's keep track of if we found X. So, found X equals, this would be false by default, and found our Y. Okay, and then we'll go with a depth first search. So we can call create driver void DFS. Node, and we could also pass in parent, I guess, to see. We'll call this check if cousins, and this will take in our roots, and then we're also going to be passed in values x and y. And then we're going to want to do a depth first search. And then for our depth first search, we should pass in, let's see, roots. We can actually, no, I want to switch this back to a map. This will keep track of our depth. And then we'll do one for the parent.
Switching back to a map.
Yeah.
Is this easier? Or?
Yeah, I think just to keep them stored and take them out when we need them. Actually, we can do like you said, like we store them in here, and then once we find them, we can just grab, or we can just go through, fill this up, and then just grab it at the end and compare. Just to kind of get a solution. This would be the parents. This is complaining because we don't have a Trino class. Well, let's just assume we have a Trino class.
Well, also the values in the tree are unique.
Mm-hmm. Okay, so what I'm thinking about doing is doing a search here. We get a node, and then we can put that. We can add the node's value and the depth of the node. And then we can add the parent nodes. Yes, we got the parent node here, and then our node's value. So, like for example, this is x. This will give our x as parent, and then this will be like x. X is at this depth, and then at the end we can compare if our depth of our x is equal to y and our parents are separate, or like they're different. So essentially, we just do a check if our node, if we have a node, make sure it exists. If it doesn't, just return. Otherwise, let's add it to our two maps. Depth parent. This will be our current node's value and where it is depth-wise. So you get the depth. We would probably need to start at the root, which will be 0, and then keep incrementing that number. So, for example, let's give it d and depth, and we just give it 0 here to start. This node value, put depth node value, and then depth, and then here we're gonna do and we should probably give it our parent. We don't actually start with a parent, so this is going to be null. Otherwise, we'll give it the parent.
Sure.
And then we'll call it again for the left and right. Let's do left first. So our left node, and then our depth will be incremented by 1, and then parent would be current node. The same thing, but this should be right. And eventually we get to the point where we populate our maps. Now we can do our comparison to see if our conditions are met. So two things we need to make sure of is if they're the same depth and their parents are so different parents, same depth. So we can do that in a single line. Do return for depth. I'll get x. They'll return the x depth value. We'll compare to depth dot get y, which compares to the y depth value. And we also want to make sure parents are separate, so our parent for x is not the same as our parent for y. Yeah, and our values are tree nodes, so we can compare these two. And yeah, I think that should be good.
Yeah. Yeah.
Yep.
I think it's good overall. It's
I don't think
working
it's like obviously the most optimal solution, but yeah.
like, what needs to get optimized?
I don't necessarily think we need hash maps. This can be done without added space complexity. More of a like we did like
How would you fix that?
let's see. So to fix that, kind of the way. Let's see if I did. Like how I mentioned before, kind of a one pass at the BFS instead of storing parents and depths for every single node. We can try and identify the X and Y as we're going down levels and checking if their parents are different. And also, since we're doing a depth first search, it's going to be a lot of calls.
Yeah. So what about if you only store in the hash map X or Y? Like, would that keep the hash map size small?
Yeah. It would essentially be just the X and Y. So that would keep it smaller for sure. It'd still be constant get. Time complexity would be the same. Yeah.
Yeah. Okay. Sounds good. We're pretty much over 40 minutes, so I'll just keep it at one question. How do you think you did? How was that experience?
I think I kind of blanked a bit on the questions. I might have overthought. I think I was overthinking some aspects and taking myself the wrong path. But
Yes.
yeah, but I mean, there's multiple ways to solve questions, so I think I'm still glad that I was able to kind of identify where things can be changed. Like even though I didn't really have time to come to, or I wasn't able to come to the most optimal solution. I think I still got some pretty good benefit out of this.
Yeah.
Yeah, definitely need to work more on trees, but yeah.
Yeah. So
Did you have any input?
yeah, I think the main thing that I was realizing is you're just over optimizing or saying that this is not optimal or it could be optimal, more optimal. You mentioned that multiple times, even though like the optimizations that you were looking for were very minimal and like wouldn't even move the needle in a real interview. So, for example, like candidates do this all the time. Like they'll instead of having a two pass solution, or they'll have a two pass solution and then they'll want to get to a one pass solution, even though that doesn't really affect the time complexity when you look at it, right?
Yeah.
Like you're optimizing space, or you're worried about the hash map solution because of space, but then there's very simple ways to like avoid that space from blowing up. But it still didn't really move the needle. What moves the needle in this question is being able to implement the depth first search, being able to track the parents in some way, and being able to track the depth in some way. Those are the
Yeah.
core things. And afterwards, when you implement that, we can work on simplifying certain aspects of it or optimizing certain aspects of it. But
Yeah.
like if a candidate is over optimizing too early, just it's not a good signal. And
Mhm.
especially if like they're offering optimizations that won't really matter and is like delaying you because it delayed you a lot because
Mhm.
you thought of this solution 20 minutes ago,
Yeah.
but then you're kind of hesitant on it.
Mhm.
So I think if now you could have got to this solution 20 minutes ago and then optimize from there. Okay, we need to
Yeah.
optimize the depth, the parent. So I think like work out the brute force
Mhm.
and don't tell the interviewer this is optimal. Ask the interviewer if this is good enough.
Okay.
So for example, if I'll when I work through these questions, I pitch solutions, and if the interview is happy with it, there's no reason for me to try to look for something more complicated or more
Okay.
optimal.
So would you say like I say my solution, and if they're like, okay, let's do it, or would they be like, oh, maybe is there a better way? So I'll kind of
Exactly. That
leave
that's
that out of them.
exactly how interviews go. So
Yeah.
you should go from the most brute force if you can think about it. Sometimes coming up with the brute force is harder than coming up with an optimal, right? So
Yeah.
if you can't think of the brute force right away, it's fine. But usually there's like a very basic brute force solution and just work your way down. Also, interviewers, it really is impressive when people could come up with multiple solutions to a question from
Mhm.
like from unoptimal to more optimal and slowly
Yeah.
optimize it on the way. So they're like, okay, this is the brute force. Okay, this is the one pass with extra space. Oh, but we
Yeah.
could actually get it with one pass, no space. I
Mhm.
mean, it really shows that they're really thinking through the different bottlenecks and figuring out how to optimize it and know multiple ways to solve the
Yeah.
question. So I think that's where you want to get to eventually, and you should like propose solutions and check in with the interviewer to like, what do you think about the solution? And
Mm.
maybe I'll say, oh, that's unoptimal. Let's try to optimize X or Y. But like,
Mhm.
don't like shoot yourself in the foot in the interview by saying, oh, I have this algorithm, but it's not really good. Like you're basically like
Yeah.
talking down on your algorithm a bit.
So should I prevent being verbal about having an optimal solution initially then?
Well, first off, when it comes to brute force, yeah, be like, okay, this is the brute force, right?
Mhm.
When you say brute force, it's automatically non-optimal. Okay, I think
Yeah.
this is a more optimal solution. What do you think about this solution?
Okay.
I mean, it definitely gets it. You just there's like a middle ground. Like you could never say it. Say that.
Mhm.
Say what's wrong with your algorithm. But if you never say what's wrong with your algorithm, the interviewer will overlook it. You're on
Yeah.
the other side where you're saying all these things are wrong with your algorithm, but
Mhm.
they weren't really that wrong. Like it wouldn't move the needle too much. So
Okay.
at your point, you're talking too much. So it's
Yeah.
finding the middle ground of not overlooking things, but like if an optimization is not going to move the needle, maybe bring it up, but just say we can optimize it later. It's not going to really move the needle right now. I could probably come up with ways to optimize it easier later on.
Yeah.
Yeah. So
Mm.
yeah. Otherwise, let's see. Yeah, you're able to implement it. Code looked good. Otherwise, it just took a while. So just getting up to speed.
Mhm.
And yeah, I think the part that really tripped you up was coming up with how to figure out the parents and
Yeah.
understanding that they have to have different parents.
Yeah. I was just kind
So
of blanking on that at first. I was just
yeah,
like, yeah.
yeah. Obviously, with more practice, you're gonna be good. You're able like coding wise, you're fine. So yeah, no
Mhm.
concerns there. Just working through multiple solutions from brute force to most optimal, and just actually realizing what will move the needle in the interview
Yeah.
will be really important.
Mhm.
Because imagine you're working on a project, right? And you think that there's obviously a more optimal way. Is there a trade-off with implementing the most optimal way in real life coding?
Mm. In real life coding,
Yeah,
like you
like
mean like in a
like
work?
in a real job,
Yeah.
should you just optimize it to the fullest right away?
No, probably not.
Like what would be the downside?
Well, I think one would be from like my experiences, time, like just trying to rigorously just oversolve a problem.
Yeah.
And sometimes like there might be cases where like we're working on like some C++ stuff that is like really performance, like performance is huge, but then there's like cases where sometimes you need better space over performance, and there's like a bunch of, I guess, factors that go into it. So just focusing on one thing is though.
Yeah. I mean,
Yeah.
deadline is the main thing. Like everyone has to hit deadlines, especially in an interview. You have an
Yeah.
hour. And yeah, like people like over optimize things way too often.
Hmm.
And I think for me, honestly, having code that's more flexible is more important than optimal.
Yeah.
Because if it's flexible, things are going to change. Like the requirements are going to change. If your code is flexible to change, you're going to be able to adapt your code. Because, I mean, working at startups and stuff like that, you don't even know if that code is going to be used or if that feature is actually going to work. You kind of need to get something that's going to work, get it in front
Yeah.
of users to start gathering data, but have it so that we can adjust and be flexible based on the data that we collect. So it's not
Hmm.
always like even in the real world, like over optimizing. Like don't worry about it too much.
So I guess my question to you is like, if I wanted to, do you think LeetCode 150 is the best for me right now to like go through and build my skills?
Yeah, I would say like my list is more when you already have a good basis.
Yeah.
These are questions that are specific to interviews. So I built that Peralta 75 list from questions that I actually encountered.
Yeah.
But they're like those the neat code 150 is probably better for beginners.
Yeah. So you think like what LeetCode 150 straight into the Peralta 75?
Yeah, or even not
Yeah.
like I don't even know if I would run the neat code 150. I would just study topic by topic, then pick questions from each of the lists, like go into some blind 75 array questions, but I didn't find blind
Mm.
75 array questions that helpful. But just when
Yeah.
you're working with array topics, just work on questions that first understand arrays from scratch, all of the
Hmm.
different functions related to array, the runtimes, like the
Hmm.
whole theory, be able to implement an array from scratch, understand how it works. And then
Okay.
from there, start working on array questions. And you could pick from like any of those lists or like use LeetCode to find good questions, but just focus topic by topic until you covered all the topics and you're pretty comfortable.
Yeah.
And then just start working on company specific questions.
Hmm.
But
Okay.
yeah, I think LeetCode has a good list though.
Yeah.
All right. Sounds good. Thanks for coming
Yeah.
out.
Yep. Thanks for the interview.
All right. Catch you, man. Peace. All right, chat. 5 minute break. 5 minute break. Chat, we got one more person. Let's get it. Woo. Let's see. Toronto. Yo, what's up, man?
Yo, how's it going, James?
Pretty good. What are you up to today besides this?
Low key, nothing really. I'm just doing some practice because I got an interview on Monday.
Ooh, shit. All right, let's get into this then.
Let's get to it, man.
So let's see who we got today. Somebody from Toronto Metropolitan University, 520 elite code questions. That's a lot.
Yeah, I've been doing this since first year, so
And what year are you in right now?
I just started third year.
Okay, still early. So what interview do you have? Shopify?
No, it's Microsoft.
Ooh, okay. Damn. All right. This is good. This is good then. How you feeling for it?
Not too bad. Honestly, like I looked at the tag question, and Microsoft don't ask hard questions, so
Yeah.
fine.
Think it'll be a breeze?
Hey, we'll see.
I mean, let's see where you're at. Like, how are you feeling with like arrays, linked lists?
I don't like linked list, but like I could do it.
Everything's fair game?
Yeah. Let's see. Oh, I gotta make an account.
Just put your name. You don't have to use an account. You just throw a name in there. I think you could just hop in anonymously.
Oh yeah, we got it.
These are the same type of coder pads you're gonna use in most interviews. So yeah, you need to be able to work with them.
Yeah.
So
See my message?
yeah. It's an interactive code editor. I see exactly what you see. When you run the code, I see you run the code at the same time. It's pretty live. But do you know what they're gonna ask you? What kind of questions?
I think basically everything's fair game.
All right, let me run the list and then just ask you frequent.
Sounds good.
What other interviews you got?
I did Bloomberg.
Ooh,
I did my final round like 2 days ago, and then
nice.
I got Snowflake and
Damn, bro, you're cracked. You got all of them.
nah, Snowflake's gonna be tough because these guys are like gonna fry me, you know.
Yeah. So how many leak code questions have you done when it comes? Like, what's the breakdown? Easies, mediums, and hards.
So I was low key. I was just doing daily every day when I was first year, but now I think let me just check actually. I've done like mostly mediums and then a couple hards, couple medium. Yeah, so like 186 easies, 277 mediums, and 58 hards.
58 hards? Okay, damn. Oh, all right. This is gonna be good. Were you tuned into the stream earlier or no?
Yeah, in the beginning, yeah. I see my boy Ruben. He got
Oh,
Google.
okay. Nice. That's crazy. You know him too?
Yeah, we used to do leak code together
No
2 years ago.
way. All right. Okay, let me find you a good question because you're pretty good already. Let me look through my list. Let's see.
Also, could I switch this to Python real quick?
Yeah.
Does it switch for you too?
Yeah, it's good.
Okay, perfect.
You haven't used this before?
Not this one exactly. There was something else, but it had like a drawing. Oh, never mind. Yeah, I have used this before.
All right, I'm gonna ask you this question just because I know somebody I know got asked the same question.
Okay, let's see it.
But he was a new grad, but you did a few questions. I gotta ask you something.
Oh, this alien language translate
Oh, you
thing?
already done this?
Nah, I probably maybe I don't know. I just like there's so many questions with the language translate. Okay. I'll just start reading it real quick. So it says there's a new alien language that uses English alphabets. However, the order of the letters is unknown to you. You are given a list of strings from the alien language dictionary. I think I've seen this before. But...
Okay. I'll ask you a different one. Don't worry. Don't even worry. Let's see.
Okay. I think I did this like in grade 12. I had a
Holy.
yeah, it was on the exam.
All right, let's see this. Grade 12 exam? That's crazy. All right, let's see how you get this question. Some people flop this. All
Okay,
right,
let's see.
you're given a root of a binary tree with unique values and an integer start.
At
And
minute 0.
Yeah,
Okay.
go ahead. Go ahead.
Okay, so it says you're given the root of a binary tree with unique values. Okay, and an integer start. At minute 0, an infection starts from the node with value start. Each minute, a node becomes infected if the node is currently uninfected.
Yeah.
The node is adjacent to an infected cell. Okay. The number of minutes needed for the entire tree to become infected. Okay, so basically it says this. Okay, it's a binary tree, right? So does that mean that like the values? Wait, let me just reread this real quick.
Yeah.
Each minute a node becomes infected if so the root is infected at the beginning, right? Like just or the start.
Not the root. You're gonna be given a node, an integer start.
Okay. Sure.
Let me give you an example. So let's say all the nodes are unique, I think. Yeah, each nodes have a unique value.
Okay.
So you're gonna be given the root of a you're just essentially given the root. Let's say it's a node, and a start. We're gonna say start is 3.
Yep.
Just let me know how long it takes to infect all the nodes if we start at node 3.
Okay, I mean this from what I see here, I'll just write the definition of the method, but just to like see like just to get the inputs, I guess. So we call it like whatever. Let's see, like how long it takes. Okay, but before I even get to like implementing it though, so here we're given 3, right? In this first example, so and the root here is 1, right? Or we could say 4. Okay, yeah. So when we're given root, we can
Actually, no.
So
This tree looks something like this. I'll go in the drawing.
Okay, sure.
This tree looks something like this. 1, 3. Here we go. 10. 6. What is it?
Okay, and then our start is 3. Okay.
Yeah. So like pretend our start is 3. How long does it take to make the whole tree infected?
Yeah, sure. So right off the bat, what I'm thinking is, since this is a tree, but it's really not a tree. This is a graph. So what we can do is just create an adjacency list between everything, right? So we can say that 1 goes to 3, also 3 goes to 1, right? And then 3 also goes to 10, 3 goes to 6, and then 1 goes to 5, 5 goes to 4, 4 goes to 9 and 2, right? So
yeah.
So now we can just do a quick literally any graph search here works. So we can do BFS, DFS, etc. Turn this into an adjacency list, and then just do level order traversal over the like what I'm talking about. Like first level would be, so 3 is already infected, right? So first level would be 1, 10, and 6. We add all the children or all the things adjacent to 6 to the queue.
Yeah.
And then the next iteration, and we just increment the time. And then the next iteration, we go to 5, 4, 9, 2, and then that'd be basically the answer.
Sure.
Does that make sense?
Yeah.
Okay, perfect. And let's see. And we just return basically how long it takes for the thing to be infected, right?
Yeah, exactly. Just an integer.
So should I define a tree node class, or we're just fine just knowing it, because like
We let's just say we know it. We don't really need to run this.
okay, sure. So here and we take in root start, and then so we can just create that adjacency list. Oh, or let me just from collections import default dict dq. I think for now that should be fine. Okay, so now we're creating that adjacency list. So adjacency list adj is equal to default default dict and then list, and then now we have to do some sort of traversal on this thing. And so one thing here is that regularly a child would not have access to its parents, right?
Yeah.
So whenever we go down, we can just pass the parent like value in.
Sure.
So let's see. So now I'll do def, and then so we're taking in root parent value, or just parent, I guess. And then if not root, we just return, and then we do so now let's go to that drawing board. So we're at 1. Now we need to add the 2 children. So if it has children, we'll add them to like add the link to it. Okay, so if root dot left, then so we add the link. So adjacent, okay, adj, okay, I can't spell, at root dot val equals or dot append root dot left dot val. Same thing here. If root dot left or root dot right, adj, yep. And then here we just add the root dot val dot append and root dot right dot val, and then we can see like and then last one will be like parent, right? But currently there's no parent, so if parent, so if the parent exists, then we can just add a connection to that as well. So
Just doing a JC root.
append, I guess we could just send in the parent value, right? So okay, and then after we do all this, so here we would be 1 goes to 5, 1 goes to 2, and then 1 goes to nothing else. When we get to 5, we can hold on. We don't have to. Do we have to pass the parent? Oh yeah, we do. Yeah. Okay, so now we can do dfs root dot left, and then root dot val dfs root dot right root dot val. So now okay, let me go through this logic real quick, just make sure everything's perfect. So we're at 1, we add 5 and 3, and then we add nothing else, right? So then we get to 5. At 5 we add 1 and we add 4, and then we get to 4. At 4 we add 5, and then 9 and 2, and then we're at 9. We only add 4 because there's nothing else, and we get to 2 and we add 4 as well. So does this DFS make sense?
Yeah. Your
Okay.
DFS makes sense. So you're just
Okay,
building out an adjacency list, so you're converting the tree into a graph essentially.
Yep. So now we can just do
Like,
DFS.
why do we need it as a graph? What's the use of this step?
So the levels here, since the start is not the root, right? So then the levels might not be like starting from the root, right? So then this would be better if and like look pretty. It'd be much nicer if we just do it as a graph, so that for example here when we're at 3, we can say at 3, time is 0 when we get, and then 1, even though 1 is the root, it's not the first thing to be infected, right? It's the second. So then we need some sort of ordering to go along. Does that make sense?
Mm-hmm.
And then here we can just pass in false, I guess, or I guess none. Yeah. So then, now we have that adjacency list, right? Now we can do that kind of level traversal. So yeah. So now we called it. So now you do q equals dq, and then we can pass in we can pass in start and 0. So at start it takes 0 seconds, right? And then we can do while q level equals q dot pop left, and then that would be I guess curve point and time. Okay. And then now we get the level size. So level equals len adjacency list at curve point. Yeah, so this is how many things it goes to, right? And then you also have to have that like scene, right? So okay. Oh wait, I need this needs to be an array. Okay, so with that taken care of, now we have the level, right? So for I in range, and range level, and then we could do like next point. Okay, yeah. So no, we don't actually do this. So we do, we could do adjacency adj at curve point. So this is a list, right? So we could do at index I, and then we could do next point equals that, right? So we're at the next point. Then we can do if next point not in scene. So if we haven't seen this before, then we can just add it to the queue, right? So q dot append, and then we append per point. Okay, our next point, and then time plus one, and then we just count like time equals 0, and then when we pop something, we can go time equals, oh, can't do 2 times, like max time max equals the max of time and max time. Okay, so here we're going through this. Okay, so now I need to add, whenever it's not in scene, we need to also add it in scene, right? So scene dot add next point. Okay, so now we add this to the scene, so we will never go over this again, and then at the end we can just return max. Okay, I think for now this is what I'm thinking. Let me know if there's any edge cases or anything.
All right, walk me through the DFS or the BFS line by line, starting at line 50.
Line 50. Oh, line 50?
Yeah, like the BFS. I just need to make sure that code's working properly.
Sure. I'll just open up the drawing while
Or
I
just
go through it.
walk through me line by line here. Or
Okay,
I don't need to see the drawing. Yeah, let's just verify
So
the code.
we initialize a DQ,
Sure.
and we we add start, which is 3, and time, which is 0, right? So because 3 is infected at time 0.
Yeah.
And then, of course, since this is a graph and it's bidirectional, there's bound to be cycles, so we just add the scenes to remove the cycles.
Yeah.
Like we initialize scene, and then we say that we've already seen 3, so that if we were to go to 1, then even though 1 has a link to 3, we've already seen it, so it doesn't matter.
All right.
And then here I'm just initializing a max time, so the max time we've seen, right? So this will be the final thing we return. And then here I do while the queue exists, so while the length of queue is greater than 0, we take the current point, so now it's 3 in time, which is 0, right? So
Yeah.
and then we update max time, and at this point it's just 0, right?
Sure.
And then we find how many things per point has a edge to, right?
Sure.
And then so here we find this 3, right? So for I in range 3, so that we're going up till 3, and then we get the next point. So let's just say here the next point for 3 is 1. So at the adjacency list at 3, the list like first in or 0th index element is 1. So then we say if 1 is not in scene, then we add it into scene, right? So we have 1 added to scene, and then we also append it to the queue, and then we increment the time, because that means that this is like the next cycle, right? Like the next minute.
Yeah.
And then that's about it here. And then here these 3 1, 10, and 6 would be added to the DQ with times 1, 1, 1, and then 10 and 6, there's nothing else that goes to them, so those points won't be added. And then also max down will be updated to 2.
Yeah.
And then at 1, it'll be 3 and 5, but we've already seen 3, so only 5 will get added with time.
Yeah.
2.
All right.
Yeah, and then
I think you're good. Let's move on to the second question.
sure.
We're gonna stick in the topic of trees, but I'm gonna give you a slightly harder question.
Sure. I applied to that Kleiner Perkins thing you posted as well.
Hey, good luck.
Thanks, bro.
All right, so we're gonna be given an undirected tree consisting of n vertices numbered from 0 to n minus 1. Some of the nodes have apples in those vertices. Just return me the minimum time it takes in seconds to collect all apples in the tree if you start at the vertex 0 and you come back to that vertex. Have you solved this question
Okay.
before?
I don't think I've seen something about apples, but I think it was something else. Okay. I'm gonna go and
This is the
have a
input
read
this
over.
time. Yeah, this is the input changed now. This is
Okay, perfect. So we decide where. Okay. And then okay, the has apples is basically like if index 0 has apples, index 1, etc. Right?
Yeah,
Okay, perfect.
like node 0.
Mm-hmm.
Like the index is the node.
Okay, makes sense. Okay, so let me just read this real quick. Given it undirected tree consists of n vertices, no, we're okay. Which some have apples in their vertices, you spend 1 time seconds to walk over one edge of the tree. The minimum time in seconds you have to spend to collect all apples in the tree. Starting at vertex. Okay, so like we have to come back to vertex 0, which is like the thing here. Okay.
Yeah.
And then so this then technically it means that for certain like oh wait, did I move something? For certain things, then we don't have to like even though you're going through a cycle, like it might not like it might be a way back to 0, right? So then you still have to go through it. Okay, this is a little bit more tough than the last one. Okay. I connect vertices. Additionally, there's a Boolean. Okay. So let me just run through this in my head and then
Feel free to draw it out too if you want.
Okay, yeah. So okay, we need okay, so I mean first year, of course, when we're given like this thing, we can just turn it into an adjacency list again. and we can like do some sort of like I'm just thinking like some sort of like heuristic thing, like only going down a specific path. Wait, this is bidirectional, right? Oh yeah, perfect. Okay, never mind then. Okay, that kind of guarantees that we can reach back to the root, right? So that's a good
Do
thing.
you understand why the input and output is the way they are? Like why the answer is 8 given that input?
So no, I'll just run through it then. Okay. Okay, so here 1 goes to 2. Okay, so I mean 0 goes to 1, 0 goes to 2. And but 0 and 1 don't have apples, 2 has apples. So figure out where represents tree red where red has an apple. Okay, wait. So if you go over vertice, then if you go over the same thing twice, then you get 2 apples? Wait, let me draw this out.
Draw out the tree.
Yeah. Okay, so make a circle right here. Let me paste this a bunch. Okay. Let me like make this gather drop bigger. Okay, so here this is 0, 1, 2, 3. I had this at 7, right? So 4, 5, and then I'll just copy this and just paste it in 2 times. Okay, then 6, 7. Okay. Okay, so it says that 0 has an edge between, and this is a bidirectional edge, so I'll just use this thing. Okay. Okay, and then what's the next? 1 and 4, right? So just put 4 somewhere here. And we put 1 and 4. What else was the other one? Need to make this smaller. Okay, 1 and 5. Let me just move this away. 1 and 5.
Yeah, it's gonna be a tree.
Yeah. Oh, okay. So the input's just different, but it's basically a tree again. Okay. Okay, 1 and 5, and then 2 and 3, right? So 2, 3, and then 2, 6. Oh wait, we don't need this. Oh, okay, it literally is a tree. Okay, that makes sense. Okay, and then so here, 2 has an apple, and I guess I'll use like a
You can
this
mark
thing.
like a different color or something if you want.
Oh, color. Oh,
Yeah,
how?
you can choose color.
Oh, I can add colors. I don't see it. What number is
Or
it
at the
Oh,
bottom.
okay. I think no, I don't see anything. I'll just use Oh wait. Oh, okay, I see what it is. Okay, I'll just use light blue to mark that it has a color. Okay, so
That has an
Okay.
apple.
yeah. Oh yeah, it has an apple. Okay, so there 1 has an apple. 2, 3. Okay, and then 4 has an apple, right? Oh, and then okay, I see why it's 8. It's just because that's how many seconds it takes, right? So and then 4 and then 5 has an apple, is right as
Yeah.
well. Okay. Yeah, let me just add that. And then so here we have to go to. Okay, wait. Since it's a tree, then we can guarantee there's no cycles. Okay, that makes it much easier. Okay, so here we're starting at 0.
Yeah.
Let's just say we go to 1, right? There's an
Yep.
apple there. That's time 1. We go to 4, time 2. We go back to 1, time 3, back to 5, time 4, time 5, and then time 6. Okay, so then why is this 8? 1 second. Watch it return them. Oh, wait, I don't. Let me just run through this again. And wait, can I spin this? Okay. Okay, wait, that makes it unclear. Okay.
Yeah, it's harder now. It's harder to visualize it when it's sideways, huh?
Yeah. Okay. Let's run through this one more time. So, at 0, it's at okay. So we can we can say that each edge is like 1 second, right? So here we count 1 second to go to 1, and then we're at 1. Takes 1 second to go to 4, so that's 2, and we go back and it's 3, and we go to 5, now it's 4, now we go back, now it's 6, and then we go to 0, so it's 7. So
I mean, just draw it out like this is one small tip. Just draw out line 1,
okay.
2, 3, 4, 5, 6.
Okay, but like,
Did you mark
that's
it right?
wait, let me check real quick. Okay, 0 goes to 1 and 2, yeah.
Oh no, 2 has a 0 vertex.
Oh yeah, you're right. Wait, let me just erase all this. Okay, well, there we got rid of that. Okay, so 2, 3, 4, 5. So 4 and 5. Okay, the 4 and
Good.
5 is still fine. So it's just okay. That was one little mistake. Okay, let's go ahead and get rid of these.
You still need to go that way though.
Yeah,
But yeah, just
I'm just
go
gonna,
draw
like,
it out. Draw it out.
yeah. Okay, which one is the? Okay, so this is 1, and then this has nothing, right?
Yeah.
And then we go 2, 3, 4, 5, 6, 7, 8. Okay, I see it. Okay, so then this is like um a minimum spanning tree problem that, and the only nodes that we need to care about are like are the ones with apples, right? Okay, so let's think about this algorithm wise, right? So we're at 0, or okay, this one's kind of tough. Let's see. Okay, so I'm sure we still need to turn this into an adjacency list, but like we can say that we don't need to go to 3 and 4 or 3 and 6, right? Like, because they have no apples as children, right? So then we can like early, that's like optimization. I guess it'll still be O of n, but we can not go down certain subtrees. And I'm just thinking like how would I make sure that a given path is the shortest? Wait, let me do something else. So let's see that instead of going down left, like we go right. Okay, we're at 2. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then it basically doesn't matter which way we go. We just have to do some do a DFS and only go down. We can only go into the nodes which have apples. Does that make sense?
What happens if we go down to a node that doesn't have apples?
Okay, but we'll only go down to a node that has apples if their children are going to be apple, or that doesn't have apples if their children are going to be apples. Like here, if we go to 3, that's just a waste of time, right?
Yeah.
If we go to 6, it's a waste of time. So then there's no point going into that.
Sure.
Okay, so then when I'm building this adjacency list, I should like somehow indicate if something has apples or not.
How do I know though that my subtree doesn't have apples?
So that's what I'm saying. I'm gonna like do some sort of pre-computation and say that for example here at 2, we'll return true if anything to the left has an apple, and then or like when we're at 0, we'll do some sort of traversal. Yeah. So then, after we do this traversal, we'll check if any node under 0 has an apple, right? Or under 1 has an apple. And then if it does, so when we're at 4, we'll return true. And then when we're at 5, we'll return true. And then we'll only add these as things which are adjacent if they do contain apples or anything under them contains apples. So we'll just do like false or false or true, or like that kind of chaining, I guess. Does that kind of make sense?
Okay. Yeah. I mean, how does that work up to the final solution?
So
Like,
initially,
I don't get your final solution.
okay,
Well,
so what I said right now was just purely building the adjacency list and like pruning the subtrees which don't contain apples.
Sure.
And then so then we'll have this, right? So okay, wait, I keep on drawing small dots. Okay, this thing and then delete. So we prune 6 and 5, right? Then now we just basically we can just do a normal DFS and just count. Okay, so then now we have this where we start from 0. We can go down left all the way to 4 and 5, and then when we're coming up, we also add 1, and then we go down 2, and then when we come up, we add 1, and then that way it's over. You kind of get what I'm saying here?
Yeah.
Okay. Okay, so then should I kind of just start coding and of course I'll probably have like more questions, or I'll see some more.
So first you're gonna prune it. So we're gonna know, like, what do you mean prune it? We're gonna know for each node if any of its subtree has an apple.
Yeah, that's it.
How are you gonna store that mapping?
That mapping, so it's gonna be like, that'll be like pre-computation basically. I'm thinking like,
Yeah, like what data structure? Like you pre-compute it, right? What are you gonna store it in? Like
in an adjacency list.
An adjacency list.
Yeah, like so what I'm thinking is I do some sort of traversal. So I'll only add like a certain edge if it has children which contain apples, and we can just create like a method, like, or just a DFS. See, oh, does anything under this have apples? If it does, you add it. If it doesn't, you don't add it. To the link, for example, like we go when we're at 2, we say, does anything to the left of 2 have apples?
Yeah.
If it does, then we add 2, and then we go to like, let's say 1. We add 1, and then we go to 5, and we say, does anything under 5 have apples?
How would you know that from 1 though?
So
what if the apple's deeper down the tree than just right under it?
Oh no, so I'm okay. Let's see if I can just delete all of these ugly lines real quick.
Like,
okay,
so I just want to make sure that.
Yeah, let's just make this deeper actually. Then we can just move 4 and 5. Just say like we both have apples, so just paste that, and then we'll add.
Dude, I'll make the tree for you real quick.
Okay.
So say 7.
I want to track that, so it's a little bit of effort. Okay.
Let's do this. Let's say 7 actually has.
Okay, so whenever we encounter apples, right?
Yeah.
So here at 4 or 5, we're gonna return true. Okay, so we're at 1, or we're at 0. I say, does the left subtree have apples?
Like what kind of traversal are you doing here?
it's gonna be I don't know the name, but it's like you go all the way to the bottom and then you go back up like
Post
I don't
order, pre-order,
yeah
in order.
it's, I don't know them by name. I
Alright,
just know
okay.
like just the like it's just three combinations of ways
Sure.
you can like
Yeah.
process them. Okay, yeah. So we we the main point is we process like the root last, right? So
Okay.
here when we're at 1, we return false, or does the let's say like does the right have does the right have a child or a child with apples? Okay, so we go to 8. Like we do DFS at 8 now. Okay, we return another false, and does the child on whatever like this child 4 have an apple? And we see 4 does have an apple, right? And then there's nothing else to 4, so then we can't go anymore. We return true, and true or false, which is true. So we do add it. Does that make sense?
Okay.
And
Alright.
then here
Okay. Go ahead and implement now.
Okay,
Makes sense.
it's kind of I don't know if it's like the standard way of doing this, but we'll just like go through and see. Okay, def, and what is this called? Min time to collect apples, and then we're given n edges has apple. Okay. Now we turn this into a adjacency list first. So okay. Now we just go from to and edges.
Why do we turn this into adjacency list?
So I was gonna just do an adjacency list first, then
Okay.
then after that do the pruning for it. Like,
Alright.
or let me see if I
That
can
makes sense. Makes sense.
do the
Because we're
pruning
given
here.
edges. We're given edges, so
Yeah, like it's just not efficient traversal if it's edges, right?
yeah. Makes sense.
Okay. So I'll
I
just
thought
go.
I thought for a second we were given the node, but I forgot.
Yeah, I thought it was like it would be more useful if we didn't have it like as a root or something, but okay. Adjacent from dot append to, and then adjacent to dot append from. Okay, now we build that. Now we have to do like that pruning thing, right? So, and we can always just start from like 0, right? Because it's a tree. All right. Root. Okay, and then if not root, return false. And then we do I guess I'm thinking maybe I just make like 2 adjacency lists because it'll be kind of effort to like update this one after.
Sure, it works for me.
Yeah. Okay. Like, list. Okay. Okay. So now we check if the root is if the root is has apples, right? So we do if has apples and at index root. Then we do add equals true and DFS, and since it's a tree, we can just do like wait, actually this might be like a little weird. Because I want to go through the subchats only, so you just do like it's like kind of a tree, I guess. Okay, so DFS. Okay, this is kind of okay. If apple is for I in we can just do for I in adjacency at root DFS, and then it's like equals false. Like add equals false. So this is like, oh, do we add this subtree, I guess? And then DFS I, and then we also add I to scene, so scene dot add I, and then so here we do add equals true and add equals true and that, and then I guess it's, and then if it doesn't have it, so then if has apples at root, if not, or I can just do else. Else, and we do the same thing. So I guess the DJ and Brian J at root scene dot add equals, or like equals false, or, and then we can do this actually or too, or DFS
If it has apples.
So that basically what all the changes, like this one conditional over here, and then at the end, so this is like when we're at like 4 or 5, right? So we return true if root, if has apples at root, else false, and then here we have to think of like the logic. Okay, prune. Okay, so when we're at 2, has apples, nothing under 2 has apples, so then we don't add it, and then we do if add, so if add is true, then we add it. So pruned. And let me just think. Okay,
Why is there a different path for has apple or doesn't have apple?
Because it's just the value here. So if the current one has an apple, then we guarantee that it does have an apple, and we go right. Okay. Then I think I don't need this.
Yeah, maybe you could just initialize that here.
Add equals like true if if has apple at, let's see, has apple at root, else false, and then we can just remove this, and then we can do like, okay, I'm thinking like this, each one is a specific edge we have to add, right? So then and then we also have to check like not going back. So if I not in scene, okay, that's fine. If I, okay, then wait, we can just remove this. And then we
Yeah, like remove that whole if.
Yes. If I not in scene, then we add it, and then here we have to have that logic of pruning it, right? So then then we do. Actually, I think it's kind of irrelevant if the current thing has it. Now that I think about it. I'll think about it later, like, or after I implement this part, right? So here we do the DFS, and we just want to find if, okay, and then after we're here, oh, that return thing, return true if has, yeah, I'm getting a FaceTime. Hold on, let me
It's
just-
all good. It's all good.
if has apple at root, else false, and then,
Well, you could just simplify that if or just has apple.
oh yeah, has apple.
So we're at 50 minutes, so I'm giving like slight.
Yeah. Okay, and then we can do the same thing here.
I mean, yeah, okay. What happens? What, like, pretend we know, like, what are we building here? The pruned? Like, where are you changing the pruned?
Oh yeah, I'm gonna do that over here, right? So then, this indicates if any. Let's see, actually. Okay, so when we reach this, we return true. When we're, okay, then that means that. So then, if we do if DFS, so if anything there, if any of the trees under it have apple, then look, this is useless. If anything under it has, it's true, so it does have apples, then we do pruned at root dot append I. So then we only add it if it's true. Damn, this low-key took me a while, and it's not that much. Okay, does this make sense?
Yeah. So this has you. Let's say we have the pruned tree. So pruned is just like a. The pruned is just an adjacency list, and all of the edges there are part of this pruned tree. So we're not
Yeah,
wasting.
Yeah, and we can guarantee that we have to visit everything if we want to get to the final.
Okay, so like how are we gonna actually calculate the final result now? Let's assume that we have this pruned and it's working.
Okay, so then we have to do another DFS here. So, so we go down basically everything, and we add two, right? So like one going down, one coming up. Or wait, actually, let me think if there's like some little bit of a smarter solution here. So we have to go down every edge. Every edge costs 2, right? Like
Yeah.
going up and down. So then we can just find the number of edges times 2, and then that would be our answer.
Yeah.
Okay, so then number of edges are, wait, then I think we can just do it we might be able to do it here. Like, okay, we added this, then we can just do like,
Well, do we need to know the number of edges or just go ahead?
or like the number of points basically, like these lines.
Vertices or
Yeah,
edges?
yeah,
Okay.
yeah. Okay, so then if this subtree has it, we don't need to add it. We can just do like res equals 0. So then if this has it, then we must go down it. Then res plus equal 2. Or we have to do some like non-local res. And then so then this basically calculates when we go up and down. And then we don't need this. Okay, look, this was not that bad. We don't need pruned. We don't need to add it. I think this should be fine. And then here we just turn res, and we have to call DFS. So DFS, and it's always at 0, right? Let me just read. Okay, starting. Yeah. Okay, I think this should be good.
Yeah. Let's see. Let me run it. Let's see. I think now you got to a solution that's closer to what I was expecting. Let's see. See if it works though. Give me the wrong answer. There's probably like a slight thing to it,
Is it off by 1 or something? Like
maybe. Like
I think
you returned.
this might
Go ahead.
be a little. Pardon?
Like, let's see, res. Yeah, let's see. If I is not in scene. If I scene dot add I, yeah. Yeah, I mean it's kind of wrong because all you're just returning is has apple. Like this DFS is not going to be proper.
Oh. Wait, is this a medium or a hard?
Medium or yeah, medium. Like you should look at your return there. Is that return proper? Like
Return has
should you return if that node has an apple, or should you return if any of its children had an apple? Like what should you return here, true or false?
Let me just think real quick.
Yeah, I think small modification you'll be able to get it working.
Yeah. Okay, then I guess we do need to check if the current thing we're at is an apple, or is an apple. So like the add, and then we do okay. So this just returns this has an apple. So it's saying anything under that subtree has an apple. Okay.
Yeah, so for example, like 1 should return true. 8 should return true, right?
Okay, yeah, you're right. So then we do like cur equals this, has apple's root, and then this could be false or true, and then we have to store if a specific subtree here had an apple. Okay, so then this will so we say if any had apples equals false. If that's true, any equals true. Return cur or any had apples. Okay, so I think this might be better.
If not. Yeah, these like small edge cases. Ew. Just trying to get yours working on my local.
All right.
Oh yeah, okay, I see what you need to change. Ish. Like it's still not gonna work. There's a few things, but or so one thing I'll just point a couple of them out is like if not root, your code will never run because you pass in 0. So if not 0,
Oh.
so you gotta remove that. Like you don't really even need to do that because you're not really gonna traverse. You have an adjacency list that only has edges. It's not like a tree where you're storing null values, so you won't ever get there.
Mm-hmm. Oh, okay. Yeah, you're right. So then I could have just done this with the stack and not.
Yeah.
Okay, yeah.
You're gonna also another issue is you're adding an extra 2 at the very end. Because you call it on 0. When 0 returns, it's not gonna be 2 extra. It doesn't take 2 extra nodes to visit the 0th node.
Mm-hmm.
So you're gonna be off by 1 there. And there's another issue somewhere that I can't figure out yet. But I mean it's close. But I mean we're at hours. So how do you think you did? How was that?
I think the first one I did pretty good. Like it wasn't that difficult, and then the second one was kind of tough, and I look, you spent too much time on getting that prune thing, like
Yeah.
and look, it was not like, yeah, I think I needed to think about the approach more from the start before I got to implementing the second one, and also like I think probably the variable names are pretty bad.
Let's see. Yeah, I think with the first question, that was easy. Pretty strong higher in the first question. No real comments. The only one small nit was, I think, when I asked you, why do we need a graph instead of a tree? You didn't really give a good explanation.
Oh, okay.
So I think just like, yeah, we need to convert it to a graph because we want to perform a BFS. And
Yep.
like we need to be able to traverse. When it's a tree, we can't traverse upwards.
It's parents, right?
We can't traverse its parents, so we need to convert into a graph so we can just perform a regular BFS. I forget what you answered, but you mentioned something else. But second question, you took the time to understand I think right away you should have worked through an example to figure out what the question is asking, because you
Yep.
thought it was it was just gonna be like the second question or the first question, but until this one you kind of have to draw out the example to figure out why the output is what it is, like to understand what the question is even asking.
Mm-hmm. Yeah, that makes.
Yeah, the solution, you're very close to solution. It's a post order traversal. I think you should
Yeah,
understand the names of the different variations as well.
yeah. That's a good thing. I like, uh, sometimes I just forget. I know literally exactly what each one is, but just by name I forget.
Yeah, like pre-order, visit the node first. In order, visit the node in the middle. Post, visit the node at the end. But
Yeah, that makes sense.
like recurse only after you visit every node, kind of thing.
Mhm.
But yeah, I think the second question was close. Yeah, just take a step back, figure out the question. At the end of the day, your solution pivoted from what you initially thought it was going to be. Like you're not really pruning. You are pruning in a way, but initially you're going to like prune it and then do another
Yeah,
DFS, but it's complete.
yeah.
Like now you're just doing one post order traversal. So like when I did this question, I was thinking of pruning right away, but then I looked at it and I just thought of a post order traversal similar to what you have here, where we don't have to perform a DFS at the end. So I think yeah, just taking a step back. It's a hard question, but you made pretty good progress on it. So
Yeah, I think this one had a couple of edge cases as well, and I think probably if I spent a bit more time in the beginning, because like just drawing it out, it might have been much easier.
yeah, but anyways, good job. We'll
Thank
probably give you a pass there on the interview.
Thank you.
All right, catch you, man.
Yep. Take care, man.
Peace.
Bye bye.
All right, stream. We're done for today. Holy, that was a grind. Let me record this. My glasses. Christian, what's up? All right, I'm gonna go hang out with some friends. Y'all have a good weekend. Thanks for tuning in, like always. Appreciate y'all. I'm checking out. Have a good weekend. Peace.
This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode,